Good morning all. Now I am going to explain about AC voltage is given to pure capacitor. Okay, now see here, let us consider a capacitor having a capacitance of C and apply AC voltage to the pure capacitor. Okay, after that current IC is flowing into the capacitor, right? IC indicates charging current in a capacitor. Already we know that the current flowing through the capacitor is given by IC is equals to C into dV by dt, right? Already we know instantaneous value of voltage is V is equals to Vm sin omega t. Okay, then charging current IC is equals to C into d by dt of V value will be Vm sin omega t. Here Vm is constant, right? That is IC is equals to C into Vm into d by dt of sin omega t, right? Then charging current IC is equals to C into Vm into d by dt of sin omega t will be cos omega t. Again differentiate this omega t, you will get into omega, right? Then charging current IC is equals to omega c into Vm into cos omega t can be written as sin of omega t plus 90. That means this plus 90 degrees is represented by plus j operator. Then charging current IC is equals to plus j into omega c into Vm sin omega t. Vm sin omega t is nothing but V, right? Then IC is equals to plus j into omega c into V. Okay, from this result, plus j operator indicates plus 90 degrees, right? That means current leads voltage by 90 degrees. If I take reference as voltage, voltage lags current by 90 degrees. Now see here, from this equation V is equals to IC by plus j into omega c. 1 by j operator can be written as minus j operator. That is V is equals to minus j into IC into XC. That means voltage lags current by, minus j means 90, minus represents lagging. Voltage lags current by 90 degrees. Okay, if I draw the waveform, okay, see from this equation here XC value is V is equals to IC by plus j into omega c, right? From this equation V is equals to minus j into 1 by j is nothing but minus j, IC is as it is, 1 by omega c is nothing but XC, right? Where XC is equals to capacitive reactance. Okay, that is equals to 1 by omega c. Already we know omega is equals to 2 pi f, right? Then capacitive reactance XC is equals to 1 by omega c, that is equals to 1 by 2 pi fc, right? Okay, this is the capacitive reactance. Units for capacitive reactance is ohms only. Okay, after that if I draw the waveform, now see here, current is started first, right? Current leads voltage by 90 degrees, right? Right, current leads voltage by 90 degrees. Okay, current is ahead of voltage by 90 degrees. Now see here, this is current is started at 0. After 90 degrees voltage is started, right? Here current leads voltage by 90 degrees. From this equation, power factor cos pi is equals to phi value will be 90, right? Cos 90 is 0. In case of pure capacitor also power factor is 0. Okay, if I draw the phasor diagram, this is voltage, this is current, right? Current leads voltage by 90 degrees or voltage lags current by 90 degrees. Okay, while representing this power factor, in case of inductor, the nature of power factor is lagging. Why? Because already we know that in series current is same, right? Okay, in series current is same, right? That means in case of inductor, current lags voltage, right? Hence the nature of power factor is lagging power factor. Now see here it is a capacitor, right? In case of capacitor, current leads voltage, right? Hence in series current is same, right? That means current leads voltage means the nature of power factor is leading, that is 0 degrees leading. Okay, blindly remember, if the nature of circuit is inductive in nature, the nature of power factor is lagging. Okay, if the nature of power factor is leading, that means if the device is a capacitor, then the nature of power factor is leading. Okay, after that the instantaneous power is power P is equals to V into I. Then instantaneous value of voltage V is equals to Vm sin omega t. Current I is equals to Im sin omega t plus 90. Current is leading, right? Then power P is equals to Vm sin omega t into Im sin omega t plus 90. Okay, sin of 90 plus theta cos theta, right? Then P is equals to Vm Im sin omega t into cos omega t, that is equals to multiply and divided by 2, you will get Vm Im by 2 into 2 sin omega t into cos omega t, that value will be sin 2 omega t. Okay, then average power over entire cycle is 1 by 2 pi integration 0 to 2 pi Vm Im by 2 into sin 2 omega t. If you simplify this equation, you will get average power is 0 only. Okay, if I draw the voltage, current and power waveforms, already we know that first current waveform is started, right, from 0 degrees. After 90 degrees, voltage waveform is started. Okay, here I can extend this voltage waveform, right. Now see here, this waveform is again divided into for one full cycle. This is 2 pi seconds is one full cycle, right. This waveform is again divided into 4 sections. Now see here, first from 0 to pi by 2, current is positive, voltage is negative, plus into minus, right, you will get negative power. After that, current is positive and voltage is positive, plus into plus, then you will get power like this. Again, voltage is positive, current is negative, you will get power in negative direction. Again, minus into minus, you will get power. That means again negative positive cancel each other, right, minus 50 watts plus 50 watts, minus 50 plus 50. Then average power over an entire cycle is 0. If you compare resistor, inductor and capacitor, in case of resistor, the average power value will be Vm Im by 2 or Vrms into Irms. In case of inductor and capacitor, average power is 0. Okay, similarly power factor, in case of resistor, power factor is unity. In case of inductor and capacitor, power factor is 0. If it is a inductor, 0 lagging. If it is a capacitor, it is 0 leading. Okay, thank you all. Next class we will solve some problems.